On your quiz. On your quiz. On your quiz, you will see no Cheetos on your quiz. Cheetos. Let's put the Cheetos away. Anything that I write down is what you can expect to see on the quiz. Now on here, you don't see a table, but you will see a table on the quiz. I just need 2 points on it. That's how many you need to make a line. Can you enter this on your calculator? Okay, we don't have a whole lot of time today. We're having a quiz on Thursday. Whether I get through this or not. If you enter that on the calculator, you could end up with 0 and -3, 1, -4. Plot the 2 points, whatever they might be. Oops, 0, -3, and 1, -4. And you will have these for your quiz. Make sure that your lines are not hand drawn. Use the rulers. Broken.
Rafi, why would you break that?
Rafi, why did you break
Mr. Gordon, Rafi breaks your things. I think you should get a referral.
I didn't break anything.
I think you should get a referral.
Look at the front board. If I copy something down, it's going to show up. You will see a question asking for each line, what's the slope? What would the slope of this line be? -1. Put something in front of that x if nothing's there. There was a subtraction sign or a negative sign, put a -1. What's your y-intercept? -3. Ask yourself, if this is a negative slope, does my drawing look downhill? It's going downhill from left to right, so it looks okay. That will get you half credit because we have a whole nother equation there. I chose to do the one where y was already by itself. You now have to take care of the other equation. Get -2x plus 3y equals 6 to look like this. So they have 3x minus 2x plus 3y equals 6. How do I get to the point where y is all by itself? Let's use green plus 2x plus 2x. almost there. What else do I need to do? Make sure everything gets divided by 3. The 3's go away. You're left with 2/3 x plus 1. 2. Could you enter that in your calculator? Could you put in 2/3 in parentheses? If you do that, you're going to get another XY table. I just need 2 points. This gives you one of the points. The point right here. That is your y-intercept for that equation. Is the slope positive or negative? It's positive. So you know your line is going to be uphill, and it'll be up 2 over 3. Over 3, down 2. So I know it'll look like this. Make an XY table for that. For that equation, you could have 0 and 2, and then I had 3 and 4. Some people like to just figure it out for themselves by substituting. Other people go right to the calculator. Doesn't matter to me. On the quiz and the test that we're going to have before the end of the quarter, I want you to do whatever I'm asking for. This one asks for graphing. On the SOL test, you can do whatever you want. You want to substitute, you want to eliminate, doesn't matter. Whatever is easiest. The last thing you're going to do is point to where they cross. That is your solution. What is that point? If it's a point, it should be 2 coordinates. What are the 2 coordinates? How about -3, 0? You always move across to the first number. So the first number will be -3. That is your solution. What that's saying is that if I use 0, the -3 and the 0, in both equations, I get a true state. It's the only point on the entire graph that works in both equations. Which one of these is the x? You could write it this way. You could separate it into x and y. Every problem's a little bit different. Pay attention to the directions and how I ask for the answer. Do you think you can graph 2 lines at the same time and find where they cross? That's what the first question on your quiz looks like. I'll have some tables. You got to fill in the table with 2 points. I'll ask for slopes and y-intercepts. No, you're too happy today. Question 2. For the quiz, what are you looking at the quiz? Yeah. For the quiz, I'm going to make you do certain procedures. When you get to the SOL, you don't have to do substitution at all. You're just showing it to me once on the quiz and once on the test. By the end of the year, you can do whatever it takes. You might find that elimination is the best method for you. You might like to graph. For substitution, you got to get one variable alone. Take a look at your 2 equations. It's up to you what you want to do. You can get the y alone, or you can get an x alone. Which one would probably be easiest to get alone and keep as a positive? X. X is kind of on its own here. It's positive. The y is negative, so that I would have to divide by a -1. So I'm going to do that. I'm going to use this equation to get that. I got x by itself. Put a big box around the other side. We can now use that chunk of information. And what's the title of this? The idea is we take that and put it into the other equation. So write down the other equation. What did we say x was? Negative 5y minus 4. That's going to go in that spot, and you're going to do some distribution and solve. This is why you learn your distribution, so that you can substitute when you have more than one equation. What goes in this spot? Negative 5y. Right, negative 5y minus 4. As long as you keep track of your positives and negatives, you're going to be fine. This is negative 15y, negative 12, negative y equals 4. Tell me what to do. How do I get my y all by itself? What should I start to do? How many y's are floating around here? I don't like that. So how can I combine them? What's in front of this y? If I got negative 15y and then another minus 1y, what do I really have? Okay. I took this and this and combined them. Now it's just a two-step equation. I'm getting that y is equal to negative 1. But if you have two equations and two unknowns, this will only get you half credit, because what do we still not have? X. What's the title of this procedure? Once you get something, now you're going to put it into this little equation that you made earlier. Put in negative 1 in place of the y. Don't forget you have a subtraction of 4 there. What's a negative times a negative? Do we have an answer for each variable? What's another way to write this instead of having them separate? How did we write it in the problem number 1? I can write it as an ordered pair. I could have done what I did in number 1. I could have graphed this and looked to see where they crossed, and I would have gotten 1, negative 1. On the SOL test, you can do whatever you want. You can graph it, you can use substitution, or you can do what we're about to do for question 3, which is elimination. All of this is getting recorded right now. You see your red line around this? So this video will show up. I'll be putting it in period 6. That's my planning period. You just look in the Unit 6 folder that's on School of Fusion, and you'll see quiz preview. So if I'm moving a little fast, go and check out the video. Number 3, elimination. Put a adding line in here. Just to remind yourself that eventually we want to add these, but only only if we have opposites. You're going to multiply somehow. It might be once, it might be twice, just to create opposites. What's in front of the x? Put a 1 there. Yep. Yep. Is 4 the opposite of 1? Is -1 the opposite of positive 7? No. But is a positive the opposite of a negative? So I'm going to focus on this. I could deal with the 4 and the 1 if I wanted to, but I'm seeing that that's a subtraction and that's a plus, so it's already sort of an opposite. I just have to change the top into that. I want to change that to look like opposites. Did I do anything to the plus 7y? No. So that means I didn't do anything to that equation. Rewrite that second equation. Nothing changed. How am I going to change the top equation to go from a -1 to a -7? What do I have to multiply by? The big 7 over there. If you multiply the middle by 7, you got to multiply everything by 7. What's 7 times 4? What's 7 times 105? Okay, I see it. Very little being written down. You have to do some sort of memorization of the procedure, otherwise you're just going to stare at your paper on Thursday. Whatever you do, try and make opposites. What's the second step? After I make the opposites, what did I do? Put a big plus over here. Add the equations. What happened? That was the whole point. What's the title of this procedure? You just eliminated the whole middle. We chose it because I just decided to do y's. I could have easily done the x's. What's over here? 735 minus 10. How do I get rid of the 29? I'm getting 25. That's nice, but how many variables are we dealing with in this chapter? 2. Which equation is probably the easiest to use to find out what the y is? I use this one just because it has smaller numbers than 105. I'm going to put this right there.
Very jealous.
It's like that. It's
Think about what we did. We created opposites. We created opposites by multiplying. Once we found something, we substituted back in to get the other variable. If you like doing elimination, you could do this with every problem. All of these procedures are interchangeable. On the test and the quiz that are coming up, you have to do what I asked. On the SOL, you do whatever you want. Last one. Yep. After I finish the last problem, I'll go on. What's the difference? What's the difference between number 4 and number 1? They both have graphs. What's the difference? They're inequalities, which means I want to know if this is solid or dotted. If you say everything, then you're right. What about the less than? What does that tell me? So what is that? We're going to shade down. We have to make the line first. 0, 8, 1, 9. Those are two numbers that'll work. You can put this in your calculator to get those points. 0, 8. This is solid. I don't listen to suggestions. I don't recommend that you just color in underneath. Have some space in between your lines because we want to see where things interlock and overlap. It's easier if you leave a little bit of space. That one was the one I chose because Y was already by itself. Fairly easy to figure out where your line is. Second one. Two X plus 3Y greater than 12. I subtracted a little, I divided a little, now my y is all by itself. You tell me, is negative 2/3 going to be an uphill or a downhill? Downhill. Is this symbol going to be a solid or a dotted line? It's only solid if you have that underneath. And we don't have that. It's downhill. What does this 4 tell me? Where should I look for that 4 in the drawing? It's the y-intercept. This is right there. I know this is downhill. If I make my x-y table, let's see. 0, 4, 3, 2.
No.
Make sure that that line is dotted.
Oh gosh.
Do I shade up or down with this type of symbol? Up. It's greater than. Where do they overlap? What part of the graph? Top, bottom, left, right? Top, over here. Label it. This is your answer. The solution is that whole area. Every single point in this area is an answer. Look for the overlap and label it. Solution. Some textbooks will have you write down solution area. So we don't get just 1 point, we get infinite points. Every single point in that area. Question number 5 will look like the last 3 problems on page 81 in your workbook. And that's what I want you to do for the last 10-15 minutes, is take a look at your workbook, page 81. Look at those last 3 problems. That's what we're going to do at the beginning of next class, right before the quiz, to make sure that people know what they're doing. These 4 problems, plus 1 word problem, your quiz looks like.
You know who drew that name? Yes.